She provides comprehensive investigation and analysis of structural failures, moisture intrusion, material deterioration, expansive soils, which we all know about that here in Colorado, building collapse, defective construction, and structural damage due to wind and snow. Sounds like the whole gamut to me. Ms. Lane also provided structural engineering for renovation design, including structural retrofit for gravity, wind, and seismic loads. She is passionate about the continued use of our built environment. So thank you very much for joining us, Nicole, and I'll turn it over to you.
Okay.
And your PowerPoint is up and going, Nicole.
Good, great. I think to summarize what Lorraine said, I'm kind of an existing building structural engineer. So messing around with problems, and then I also work on, alterations. When I say I'm passionate about our built environment, maintaining our built environment, what I mean is we have buildings. There's no reason to tear down and rebuild when we can modify them and protect them and make them last. To me, that's part of conservation. And also, I think you see on there, I also have a historic preservation avenue that I do my work in, because old buildings are cool and there's no reason to get rid of them. We can make them work for what we need. So I think this presentation was advertised as wind failures, which I'm going to get into, but first I'm going to make you listen to my lecture about what a structural engineer is and what an investigation engineer is. Because I think a lot of people maybe have a vague idea of what a structural engineer does, but I like to outline it a little bit more, try to raise the profession in everybody's mind. A structural engineer is essentially a technical consultant. There are several ways they do their work, directly for building owners, and then sometimes as a consultant on a team of design professionals. For instance, for a new building, you'd have an architect, a mechanical engineer, a plumbing engineer, etc. A structural engineer, what I tell kids when I go to STEM classes is that a structural engineer designs the bones of a building, the skeleton. They use math and science to evaluate the demand on a building, the loads, and what materials can be used to resist those loads. And then at the end of that process, they issue construction documents that a contractor uses to build the project. So here's some examples of loads to help you understand what the demand is on a building. You have wind, which acts like a fluid moving across the earth and creates pressures on buildings. Snow, of course, creates gravity loads. Occupants and their belongings create gravity loads. The building itself has its own weight that it needs to resist. There's also seismic forces, which are actually originate from the ground and shake the ground, which causes the building to sway, and that creates a force within the building. There are other forces, but these are kind of the most basic ones. And then all of that has to get transferred back down into the earth, into the ground. So those are the loads on a building. The structural engineer doesn't do this blindly. There are hundreds of codes that outline the requirements. These are produced by generally scientists and mathematicians with engineering degrees that kind of lead the way in the science of what the practicing engineer does. So the practicing engineer uses these codes. I had presented this wind failures class to Structural Engineers Congress. And so we had this example of how the structural engineer, the body of volume of stuff they need to know is increasing with time because we as a society know more. We also accept less risk than we used to. So there's a lot more that goes into the design of a building than originally. People say they weren't built like they used to be, but that's because the ones that were built well lasted. There was a lot of garbage in the past too, it's just gone. So then here's an example of the drawing that in a new construction design process would be issued to guide the contractor to build the building. So this drawing set would have drawings specific to the architect, drawings specific to the mechanical systems, plumbing systems, etc. This is a foundation plan from a structural engineer, actually me from maybe 15 years ago. So the contractor would use these documents to actually build the project. So that's kind of my quick hitting overview of what a structural engineer is. Now to drill down into the specialty within the specialty, what's an investigative engineer? And that's what I do now.
Excuse me, Nicole.
Are you advancing your
We can't see your
shoot.
screen. We only see
On
the first.
screen. Thank you so much for letting me know. Okay, here's a beautiful picture. This is the one that you probably was more interested in.
Right. Thank you.
Thank you for letting me know. Yes, so I like this one a lot. I think this helps a lot of people kind of visualize the demands on a building. So this is a cross section through a building with the different loads. This was my slide for the codes. So this is the 1988 wind code, or this is the load code, but this is the wind chapters of those codes. I think that the wind committee got jealous of the seismic committee and around 2005, and so doubled the wind code section. Oops, and then there's a foundation drawing. Okay, now let's drill in to the specialty. So investigative engineers, obviously investigations in the name. So it's determining damage, designing repairs, condition assessments, which are investigations kind of before damage is known, and then forensics, which is for legal action. And so here's just a few slides with some pictures of projects I've worked on. This was actually a new building. They're working above, and this whole section of the beam blew out the bottom. So new construction can also have investigations, unfortunately. Here's a repair design, not a very elegant one, honestly, but it fit the owner's needs. This was an old wood building, and the ends of the wood joists were failing. And so we simply put a new steel beam across to support them. This was a parking garage. Parking garages are constant investigation source of revenue for us because they're just, demands are high. There's waters and salts coming into these constantly, and they deteriorate rather quickly. In this case, this is just what we call a spall, where a chunk of concrete has fallen off the building, likely because moisture has gotten into the rebar and rust expands, pops that concrete off. Forensics, the semi truck right into this building. So forensics are part of investigative engineering when they're specific to legal action. No one died in this. We probably wouldn't show you a video of one that had. So now that you maybe hopefully have a little bit of a general overview of what an investigative engineer is, I'll share with you some fun case studies. Well, I think they're fun for wind failures. This was, I kind of cribbed this from the presentation I gave to the Structural Engineers Congress that I was mentioning to you. Here's my first case study is an interior wall failed in a building due to wind. And I think that's not something you might think would happen. But we do live in Denver, and especially the west side of Denver and the Western Slope, we're in a special wind region. So we have higher winds than a lot of the rest of the country. You know, you think of Kansas or whatever as being windy, Nebraska, their winds are more constant, but we have bursts of wind. And believe it or not, that can cause an interior wall to fail. So in this case, this building is a warehouse, so it has dock doors all around the perimeter, and a dock door was left open when there was a microburst. And so that microburst caused pressure to enter. Can you see my mouse?
Yes, we can.
So that pressurized the building. So this, acted like a balloon, blowing up a balloon, and pressurized the building. So you have this interior wall here. This is a cross section of the building, for those of you who are more visual. So that you basically pressurized this building by having that dock door open and that wind event. So here, I think you can see, I have a little drawing here of where the wall was, the top of wall. Now it's over here. So it's the top of the wall has flopped over essentially. One of the codes that I listed tells you that for an interior wall, you need to design it for 5 pounds per square foot of pressure. Most of the time, that's such a low force that no one actually calculates anything or does a design. We just have standard walls. You use 2x4s at 16 inches on center or 2 foot on center, done. But when you're in a warehouse building, those walls are extremely tall. And when you have a dock door open, they're going to get a lot more than that standard loading. So here you can just kind of see, I think you can see this pipe here. That's the fire sprinkler line that's keeping that wall from collapsing completely. Not too exciting for whoever is keeping products in there. So here's just a little bit of information from the more technical talk that I gave about the differences in pressures and why sometimes just using the standard pressure isn't appropriate. And that's pounds per square foot, if any of you are curious. Oh, there's the wall. So essentially what happened in this case is that when the building became pressurized, it actually pushed the roof up slightly. And then it also pushed the wall horizontally, causing it to bend. And these metal walls, these metal stud walls, they're constructed with a track at the top, so a C that takes the stud into it. And often they're not actually connected because you want the roof to be able to move up and down naturally with its snow loads without loading up that interior wall that wasn't designed for that load. So in this case, the track wasn't deep enough. So when the roof lifted and the wall bent out, it just slipped out of that track. So that was the cause. That was pretty much the end of my investigation there. The repair was rebuild it and make your insurance claim.
Looks like an expensive repair.
You know, it wasn't. Yeah, it probably was. In the grand scheme of things, I didn't think it was that bad. They just had to rebuild it, and the tenants were put out. I think that's when it comes to property managers, that's one of the biggest problems to them is if the tenants are put out, then that's where the more costs come rather than just the repair itself. So whenever we can, we repair things in situ for that very reason, just so if occupants can stay in the building, that's ideal. In this case, there was really no way to get that wall back in place. So they did have to tear it down and rebuild it. We actually went ahead and put a little safety measure in there. There's a product out there that's a clip that you can put at the top of this that has vertical slots in it. So you still get that vertical movement, but it can't possibly pull out. And that probably wasn't installed originally just because of the added cost. And the lesson there is if an engineer had performed a design on this using the code, they likely would have used a thicker stud so that it couldn't bend and be so noodly under that wind pressure.
Can I ask a question? So did they have to pay a fine for not being in code or anything happen?
No. Okay. There is a 7-year, what's the word I'm looking for?
Kind of a statute or something?
Yeah, thank you. That's it.
Mm-hmm.
Yes, there's a 7-year statute of limitations for one. And then typically it has to be a pretty egregious failure, you know, something that was truly life-threatening for it to become more of a legal action. You know, buildings are very complex and things fail. And so something like this normally wouldn't be. The only thing that could have been is if the building was more recent, you know, within 2 years. A lot of times contractors who have built the building offer a warranty and they would have come and repaired it. Yeah, usually it takes quite a bit for actual legal action. In this case, just an insurance claim.
Okay, thanks.
Yeah, I appreciate your questions.
So this failed because the roof went up?
It was the combination of the roof pushing up because of that pressure, you know, blowing up that balloon, and then also pushing against that wall because the wall was inside the building there's a dock door open on one side of the wall, but not on the other side of the wall. So that pressure pushed against that wall. So it's that combination, and then it just kind of bent out. So here, you might see something missing on this building. Maybe it looks okay, but this is another case of a wind failure. This building used to have a roof on this little edge here. Again, another one where no one was hurt, a lot of property damage because this roof actually flew off into a parking lot. So here's how it was intended to look. So I think, if any of you can remember back to maybe you took physics, or, a lot of kids' books talk about how an airplane works with the lift. Wind flowing across the earth has a speed, and when it comes into the obstruction, it has to go over and around that obstruction. So in the case of an appurtenance, a thing sticking off the building, like this roof here, you end up with basically a wing effect, right? So the wind is blowing over that and under it, but it's got to go over, a greater area, and it creates a suction or an uplift. I don't see any of you nodding, but hopefully you sort of remember that.
I have a question. Why
Yes.
would an architect design something like this? Knowing, this looks like it's only just for appearance sake. Does it serve a useful purpose?
I'm not going to answer that. I don't know. I think it is just for appearance.
Okay.
I think there are cases when you would want to shade your windows, certainly.
Okay.
And I think, architects, and it is nice. I agree. We don't want everything to look like a bunker in a warehouse. So it is a design feature. How about that? And I think there's no reason it should have failed. In this case, I think the engineer did not do their full job. Likely they designed, if we go back here, they probably did design these larger elements to resist those wind loads. But when it came to actually attaching the system above, I think that's where the failure was. That suction just ripped that thing right off. It wasn't properly bolted down, if you will.
Thank you.
Yeah, you bet. I appreciate the questions. It makes it a little bit more fun for me too. And then I know you're not asleep.
That must have been real exciting for the people next door.
I can only imagine. I can only imagine.
Wow.
And Boulder is another place where the winds are really gusty. So this wind could just come through, and these are rare. These failures are rare, which is good. And this, for instance, is covered by our building codes. I don't think it was properly executed. Let's see. There's a photo of, it took some of the roof with it too. I think this is the parking lot where the roof ended up. All right, and so that's moving on to the next one, unless you have more questions about that one. So that same wind effect that I was talking about, when it creates that suction on the top, it also creates suction on the back side. So on the leeward side. So in this case, wind would have been blowing from, I don't know if I'm near or not, from left to right, this way?
That is left to right that you're showing, yes.
Okay, good. And created a suction on the back side of this wall. And just sucked it right off. This one's in Gepin County. And the design wind speeds in this region were 165 miles per hour for a 3-second gust. So that's a burst of wind that can happen in a mean interval of time that I can't remember right now. To give you just some perspective, Kansas, Nebraska are 90 mile per hour design wind loads. So that's the wind speed that the engineer is tasked with designing for. I doubt this wall was engineered at all. I think it was just slapped on, and it was inadequate. So this burst of wind came through and literally peeled this wall off. So this was an exterior wall that was attached to an interior wall in sort of an odd way. Normally your exterior wall would be your structure and your interior wall would just be a finish. This was reversed for whatever reason. So the interior wall luckily stayed intact. But this exterior wall just sucked right off the building. The end result for me in this one was trying to design a way to attach a wall to another wall in situ. It doesn't sound that bad, but getting the right attachment so that it would actually stay in place was a little bit challenging. But in the end, they just put it back up and it's there. And it's designed for 165 miles per hour wind section.
Has it been redesigned?
That was repaired quite a while ago and it's still there.
The design was not changed?
Oh no, I redesigned it. Yes. I did a new design so that they could put it back and the new design would meet the appropriate wind forces. When we do these little investigations and repair projects, unfortunately / fortunately, depending on your point of view, we isolate usually to just the area damaged. So we didn't go through and repair every wall. We do look for signs of failure or potential areas of failure. This was the only wall built this way for whatever reason. And so the repair project was limited to just this, and the repair was designed to meet the appropriate standards. So those were my 3 wind cases. I thought I'd share some other failures just because we still have a few more minutes if you guys are interested. This one, so another one where the outer layer of a building fell off the inner layer. Interestingly though, this was not from a wind event. And my task on this project was to find out why, because there was an insurance claim and the insurance of course covers this and not that and blah, blah, blah. So they have to bring in a bunch of experts to argue on why this happened so they can determine who's going to pay to fix it. I think something interesting on this, the occupant of that unit described hearing squirrels in her walls before this happened. And then it just let loose. The whole thing just fell off in one go. This is a pretty common construction for the 1920s with an exception that I'll share with you. But you can see there's a stucco coat, which we call a parge coat, is a more generic term for that. On that, which is very common because the bricks in the Denver area that were mostly used in that time were very mushy, I'll tell you. They're pressed sand, practically. Some of them were fired just enough so they'd have a nice hard coating. But if you're familiar with any kind of ceramics or materials like that, they need to be cooked to harden. And these were shown very little heat. So you ended up with what I call M&M bricks, where they had a candy shell and a mushy center. And that's very common in this region. And a common solution to that is to slap a stucco coat over the top. And so essentially that stucco coat glues that face together, but it can be very insidious in that it hides defects that are happening within the wall, and you can end up with a sudden large collapse like this. This wall was built, here's the exception I was going to tell you about. What's unique about this, you don't normally see this in a brick building. The original mason got a little too clever and didn't want to see those rows that you see in a brick building. You'll see horizontal, 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 and then you'll see a row going in to the building, and we call those a header course. And those link all those stacked rows of bricks together. In this case, they didn't want to see that header course, and so they put these diagonals in to cross between the layers of bricks. So you've got your layers here. I don't know if you can see my hands, and then you've got this cross piece. So it's sort of just slightly grabbing in between the layers. So you've got soft brick. You've got 100 years of moisture, people cooking inside, get moisture in the walls, rain events get moisture in the walls, improper maintenance of your parapets get moisture in the walls, and those bricks soften. And then you can see eventually they just let go. You know, here's a broken one. and we saw piles of those. Unfortunately, that meant that the insurance company wasn't going to pay for the repairs. And that's one thing that's a little bit hard when I'm doing an insurance claim. I'm just there to provide the expert opinion. And sometimes I'm the bad guy and sometimes I'm the good guy. One thing, actually, another interesting thing on this one, because there wasn't a wind event or rain event or anything they could point to the insurance company, the owner brought in another expert to claim that it was due to trucks driving by the building, vibrating it. And so then I had to also prove why that wasn't true. There's actually been some interesting studies on that by the Federal Highway Administration, the effects of truck traffic on historic buildings. And there's several papers that, should you want to read, about hertz and frequencies.
What are those black streaks on the side of the building?
Oh, those are old chimneys and ventilation chases.
Okay.
Yeah, you can see them up here. So that's another way that moisture gets in and softens up these bricks, or through those chimneys. And you see it a lot where you can see up here someone's added modern cap flashing, which is a good idea because it keeps water out of the top of the wall, but they didn't do it on the chimneys. So those just continued to leak as well. Any other questions on that one?
So is there a fix for something like that?
I'm afraid not. They had to just reconstruct that wall.
May I make a couple of comments here? We had a little experience back about 35 years ago. I'm not a structural engineer, but I learned more about it than I really ever wanted to. And I found that there are a whole lot of people who are involved in the design of buildings. And yes, usually there are checks and balances in the design process and the construction and so on. But when you get a bunch of people who are either trying to save a bunch of money or aren't very smart, you can have real problems. The house that we had in a certain development south of C470 and between Broadway and University had about 104 homes in that particular neighborhood, and every one of them had structural problems. When they got done with ours, they found that there was a wind load problem on a 16-foot high curtain wall on the outside of the house, built with 2x4s that sort of flopped in the breeze. They had designed it in California and they forgot we had snow here. And so the roofs were made with a ridge beam and rafter type construction with nothing tying it together rather than trusses. And so that when you got a snow load, it would tend to collapse. The beams that held the second floors were not designed for a heavy enough load, and they had to reinforce those. And to top everything off, it had soil problems. And so the foundations were cracking. The whole thing for the community ended up in court. And the decision was that the structural engineers, the architects, the contractors, and the Douglas County Building Department and inspectors were all equally negligent. Mm-hmm. So if you have a whole bunch of those kinds of organizations that normally check each other, usually these things aren't going to get to the completed stage before somebody does something. But thank goodness there are folks like structural engineers who know how to do these things properly.
Yeah, you're exactly right. It's a perfect storm of nobody doing their job. There's or everybody's sort of doing their job, I guess, not doing it well. That especially in residences too, a lot of times they'll try to even skip structural engineering. And I think that our local jurisdictions have gotten more savvy. As you mentioned, that even the building officials hadn't done their proper due diligence. They really can't be held responsible, but ultimately it's the engineers and builders that would pay for a lawsuit, for instance. But they have gotten more and more savvy, and they do more thorough reviews than they used to. In rural areas, you still kind of have that Wild West, just because there isn't the resources to have that building reviewer. Hopefully you have savvy and diligent design professionals in most cases. But things like the Hard Rock Cafe failure that was very famous, I think within the last couple of years, that floor that failed in Louisiana, that was another example of that. kind of perfect storm where the floor itself wasn't designed properly, but also it failed during construction because the construction wasn't being executed properly. Usually there isn't one source of failure. And in the case, on these historic buildings, no one actually designed it. They just built it per their whim or per standards of the time. Let's see. It looks like I'm about out of time. Hopefully you got a bit of excitement of what can happen with wind. And obviously, George, you've experienced it firsthand, issues with wind. And then, I have my little masonry wall example here. Does anybody have any other questions or any other anecdotes?
Well, one comment I'd like to make is I don't know about everybody knows, but bentonite is a very big problem in this area.
Indeed.
And I know I had a house and it failed miserably. And it's ugly. In this particular area where we live, there's a lot of bentonite problems.
There is, yeah. Yeah, it's a big problem. And, I would even say it can be worse on the east side of Denver in some ways. Here on the west side of Denver, it's kind of more throughout. On the east side of Denver, a lot of it's in the bedrock, and the bedrock can be a swelling material. And so sites that were built 20 years ago the moisture will finally change in that bedrock. And then you'll see problems 20 years after construction. And we have several buildings that we just constantly monitor and repair because of that.
Well, and another issue that we have in this particular area is Coal Mine Avenue, Coal Mine Road.
Yep.
I mean, there are coal mines all along there, and there's been a lot of construction, and we've had problems in that regard too.
Yeah, you end up with unexpected subsidence, and it's interesting. I obviously work with geotechnical engineers a lot, and you would think with all the technology we have, they could map that somehow, but there's really no way to identify those until they're building and they find it.
Why would Jefferson County ever approve building those houses at the corner of Kipling and Coal Mine over the top of coal mines when they know they're going to subside?
I don't think they expect the design professionals to do the design. They really just review kind of on a big picture. And I imagine that they didn't have probably at the time, they didn't have a reviewer who could comment.
Don't the architects have any, or the builders, don't they do their due diligence as to what's underground here? And what is it, geological survey?
They do. Yeah, they do a geological survey. Every construction project requires one. So there's a geological survey performed by a geotechnical engineer. They produce a report with recommendations. The builder can follow those recommendations and usually does. But a lot of times there'll be several levels of recommendations. If you want absolutely no movement, you've got to do this. If you're okay with an inch or two of movement, you do this. If you just don't care and it's a barn and it can move all over the place, you do this. And it comes down to cost. To construct a building in those regions that won't move, we couldn't build anything ever. And so I think for them, it's a compromise of what level of risk they're accepting, which ultimately gets passed on to the owner. It is unfortunate that there have been so many of those housing developments that were done so poorly, but it's a cost. A lot of it's a cost issue and taking the cheapest option because they're just trying to churn those out.
Lori, that happened to us at Ken Carroll Ranch. The whole community of Quail Ridge and Aspen Grove was built by Brock Brothers builders, and they came from California. And it's not that they were slapping up houses like crazy in 1978 for all the influx of people coming to Martin and stuff. And no, I don't know if they surveyed or not, but we were on a pile of bentonite, and some houses had to be over in Aspen Grove. There was a whole street. They had they were unstable and they
Mhm.
couldn't possibly fix them. And we had a 10-year warranty on our house, but some of the movement was down into bedrock, and at 15 years, we had to have a whole wall dug out and anchored into bedrock. And it cost a lot of money. And, but that happened a lot there. So, and Brock Brothers went bankrupt.
Well, I know the community of Canterbury, they had a lot of problems. And I bought a house in 84 at Dakota Station. And it was a ranch, and supposedly went into bedrock with a floating floor. And I was there, I don't know, 3 or 4 years, maybe, not even that. And the windows were all cattywampus. The garage door was all cattywampus. You couldn't open up windows. Oh, the structure itself, they had to, it turned and twisted the beam along the bottom, the whole beam of the house, and it twisted it. It was ugly.
Yeah, that's what it did to our house too. It twisted the main support beam across
Yes.
the whole structure.
Yep.
Yeah.
I got a question for our
No.
speaker. I've been involved in a couple of older buildings in downtown Denver, and they have a sandstone facade, which seemed to me very porous. Is that a typical problem for some of the historic buildings downtown?
Very much so. Very much so. I think it's a matter of, Denver was the Wild West. A lot of people still consider us the Wild West. And it's what was available. You can get even worse case. Sometimes they would orient that sandstone. You might see it oriented vertically, and that just never lasts. I mean, a lot of those failed at 50 years ago, but you'll just see them erode. And you'll see a lot of times downtown on those sandstone buildings, you'll see little hammer marks in the stone, and that's where they're basically just taking off layers. Every time a layer gets loose, you go and hammer off that outer layer, and it is an ongoing maintenance problem. And there's not much that can be done about it other than replace the stone fully.
Yeah, because it just continues to crumble.
It just continues. And there's repairs out there that people do, and they buy you another 10 years, they might buy you another 20. But ultimately, it was a bad material to build with, and eventually it'll have to be replaced.
You guys are just lucky you didn't live in Houston, because you dig down 2 feet and you hit water.
Yeah.
Mhm.
We had different problems over there, but
Yep. Every location has its problem.
yep.
For sure. And the stories you guys are telling about California builders, we see that a lot. I also do peer reviews, and we'll see a builder not from here, and there's no reason they shouldn't know the local issues, because it's all documented, it's all available. You go to your building department, say, what are the local winds, what are the local snows, and it's right there ready. So there's no reason they shouldn't have that information, but we do see that.
Yeah.
You need the local information, and it's available to any engineer anywhere in the country. So there's no reason for that. Yes, I've done some, not as the engineer of record, but I've been involved in some Houston projects, and that's a big deal. Very expensive to deal with that water.
Nicole, where did you get your engineering degree from?
I went to the University of Texas in Austin. I'm a local girl, but that was my way of getting out. I forgot to tell you guys, I was actually in Key Club at Green Mountain High School. And so it's great. I love, we would go, we were invited, I think, monthly to the meetings. And I'd go maybe every other month.
Well, great.
The free breakfast, of course.
Cole, what is your service area?
The Rocky Mountain West, mostly. We have my firm, Martin. We have presence in Arkansas, California, Wyoming, and New Mexico. And so I have done some work in California, flown out there to assist our team out there. But mostly it's the Rocky Mountains, Wyoming, Utah, Colorado, and New Mexico.
So y'all think we talk funny in Texas, don't you?
You do
Sound like my
talk
mom.
funny.
The reason I got to go to UT is my mom grew up there. So
Okay.
she was comfortable letting, so it just sounds like my mom.
Yep. Well, we want to thank you for a very informative presentation there. So it's,
And
thank you.
thank you all for being involved. It's a lot more fun when there's questions and discussion.
I had a wind
It was
question.
interesting.
What's that, Valerie?
I had a wind question, but it's not with the building. We actually live over by Vandermeer Speedway, and this last summer, we came home from going out to dinner, and 4 of our vehicles had their windows blown out. And there had been a microburst when we were gone. My husband has like a little weather station so he could see, what had happened when we were gone. But is there a suggestion you might have from your perspective? Should you crack your windows when you're, in a windy area? I mean, it was, yeah.
That's very unusual. Car windows are designed to handle a lot more force than your average building window. So that's crazy.
Yeah.
I think you won the lottery.
Okay.
No, I wouldn't. Actually, cracking your windows could make it worse.
Okay.
I'm hopefully your insurance covered it, and
It did.
It sounds to me like a freak accident, kind of like that interior wall failure. That's very rare.
Yeah.
Nicole, I have a question for you. When the Colorado State Capitol was built in the 1880s and 1890s, they put sandstone pillars underneath to bedrock to support it. So there are 42 6-foot by 6-foot pillars of sandstone that go down to bedrock. The building seems to have held up fine for these 100 and some odd years. Is that type of construction ever a problem?
It can be. Especially in a seismic region, fortunately we're not. And when sandstone isn't exposed to on the exterior, it can actually last a long time. So even if it gets wet on those foundations, it's not freezing and it's not getting wet and dry rapidly. So those sandstone foundations will last for, it can, if you go to Europe, you'll see them, they can last millennia. I don't know if ours will, but they haven't been a problem. I actually have been, I do work on the Capitol maintenance type engineering, and those are still in great shape.
Okay. All right. Thank you. Thank you, Nicole.
Thank you.
We appreciate it. Now, as a reminder, next week our meeting is at 7. Okay, it's the first meeting in the month, so it'll be at 7. And I need volunteers for the invocation